This is an example of a grams to grams problem, which is learning target 7.1 at the meets level. So the first thing I'm going to do is in my equation find the information that I'm looking for and that I have. How many grams of oxygen are required to burn 3.86 grams of carbon monoxide? So 3.86 grams of carbon monoxide for every how many grams of oxygen? So from carbon monoxide to oxygen. I'm going to start by setting up a bracket with what I have. In my next bracket, the only unit I have right now to cancel out is grams of CO. And I can turn grams of CO into moles of CO. So grams of CO and grams of CO. Once I'm in moles of one thing, I can go into moles of another thing using my mole ratio. So in order to get my units moles of CO to cancel out, it needs to go on the bottom of this fraction, and I can turn that into moles of O2. Now moles of CO and moles of CO cancel. And my last step is to take moles of O2 and turn it into grams of O2. And moles of O2 and moles of O2 cancel out, and the only unit I have left is grams of O2. I know that my answer is going to be in grams of O2, which is ultimately what I want. Now I can plug in numbers. Anytime I have a ratio of moles to grams, I know that it's 1 mole for the molar mass. When I add up the molar mass of CO, I get 16 plus 12 for oxygen plus carbon, and I get a total of 28 grams. That's the mass of 1 mole of CO. In my next bracket over, when I have moles of one compound to moles of another compound, those values come directly from the coefficients in my equations above. The number that I put next to CO is 2, and the number I put next to oxygen is 1. Since there's nothing listed, we know it's a 1. And last but not least, if I'm looking for the mass of 1 mole of O2, 16 and 16 is 32. When I plug it into my calculator, I take 3.86 grams divided by 28 divided by 2 times 32. Ultimately, I get 2.2 grams of O2. For 4b, how many grams of carbon dioxide are produced if we burn 65.9 grams of oxygen? So I'm going to set up my bottom here with different numbers. Now I'm starting with 65.9 grams of oxygen. And I want to know how many grams of carbon dioxide are produced. So now I know I'm going from O2 into CO2. So just like before, let's start with what we know. We know we have 65.9 grams of O2. I'm going to set up another bracket where I can cancel out grams of O2 by putting it on the bottom. The only thing I can turn grams into is moles of that same compound, so moles of O2. Grams of O2 and grams of O2 will cancel. If I set up another bracket, I can cancel out moles of O2 by putting it on the bottom, and I can go from moles of one compound into moles of another. I'll put that other compound up top. Moles of O2 and moles of O2 will cancel. And last but not least, if I put moles of CO2 on the bottom, I can turn that into grams of CO2 on the top. Moles of CO2 and moles of CO2 cancel to give me an answer with a unit of grams of CO2. Now I can plug in some numbers. Anytime I have a mole and gram ratio here, for every 1 mole, I need the molar mass. In my second set of brackets here, I have moles of CO2 and moles of O2 being compared. For every 1 mole of O2, I have 2 moles of CO2. And remember, those come directly from the coefficients in front of our balanced equation. And in my last bracket, for every 1 mole of CO2, I need to know the molar mass of CO2. So 2 oxygens plus 1 carbon, 44. when I put this into my calculator, 65.9 divided by 32 times 2 times 44 gives you an answer of 181.23 grams of CO2. Now you try the next grams to grams problem on your own.